Sample problem 10.7. Carbon dioxide is effective in fire extinguishers partly because its density is greater than that of air. So carbon dioxide can smother the flames by depriving them of oxygen. Air has a density of approximately 1.2 grams per liter. At room temperature in 1 atmosphere, calculate the density of CO2 at room temperature, which is taken to be 25 degrees Celsius, and 1.0 atmospheres. Okay? So here's the idea. You got this fire extinguisher with a hose. You spray it onto the fire. The fire is right here, right? There's your fire. Okay, you spray it at the base, and it's more dense than air, so it stays down here near the fire and smothers the fire from the bottom up. Okay? If carbon dioxide were less dense than air, then it would essentially float up, and it wouldn't be able to put the fire out. Okay? But it tends to linger down here. Okay, so this is a pretty straightforward problem. There's a couple of equations that you can use to do these types of problems. One is the molar mass of a gas that obeys the ideal gas law is the density of the gas times the gas constant times the temperature in Kelvin divided by the pressure. So the molar mass is the m on the left, and we can rearrange this to find that the density is equal to the pressure of the gas times the molar mass divided by RT. So in this particular problem, they want to find the density of carbon dioxide, not the molar mass, but the density. So we need the pressure, which is given, 1.0 atmospheres. The molar mass isn't given, but we can find that out from the chemical formula and use the molar masses from the periodic table. Gas constant is 0.08206, and then the temperature is given as 25 degrees Celsius. So let's find the molar mass. Carbon dioxide, there's one carbon. Two oxygens. And there you go. 44.01 grams per mole is the molar mass for carbon dioxide. Okay, almost everything else is given. We just got to convert the temperature into Kelvin. So the density would be 1 atmosphere times the molar mass, which is 44.01 grams per mole, divided by R, times T. Our dimensional analysis, atmospheres cancel. Moles are both in the denominator, so they cancel. Kelvin is in the numerator, denominator, so it's grams per liter. We know it's got to be greater than 1.2, right? Because it said in the problem that carbon dioxide is more dense than air, and air has a density of 1.2. So 1.0 times 44. Let's try that again. 1.0 times 44.01 divided by 0.08206 divided by 298.15. Oops, let's try that again. I'm going to come back over here. 1 times 44.01. Divided by, let's put it in parentheses, 0.08206 times 298.15. 1.798. Let's just round that to 1.8. And lo and behold, it is, right? Carbon dioxide is, in fact, more dense than air. Air is about 1.2 grams per liter, and carbon dioxide is about 1.8 grams per liter. Remember the density of water at room temperature? .997 grams per milliliter. That's per milliliter. So that would be 997 grams per liter. So liquid water is a lot more dense than carbon dioxide or air. It should be, right? It's a liquid.